We're here with Chapter 4, Lesson 3. This is a bigger chapter. There's a lot more sections. There will be a few more videos to break things up a bit. The key questions for this lesson will be, what is the difference between speed and velocity? This is touched on a little bit in Lesson 1. I'm going to expand on that. And how can we calculate speed? Turns out there are 3 different types of speed that we can talk about. We're going to mention those, so pay attention. Here we go. If we think about things that are fast, one thing that comes to mind is Usain Bolt. If Usain Bolt were to race me, he would win. He can go approximately 11 meters in 1 second. If you think of our classroom, that's the better portion of the length of that classroom in 1 second. That would be about 25 miles per hour. However, speed is relative. We're going to focus on that. Here, for instance, whereas Bolt could go 25 miles per hour, this car can top out at 200 miles per hour. This is a very fast sports car called a Bugatti Veyron. Still, not the fastest thing out there. If we expand our minds here a little bit, this actually is mind-blowingly fast. This is an SR-71 Blackbird. It can go across the United States of America in about 1.5 seconds. That's fast. That's incredibly fast. That's mind-blowing. And yet, the Earth itself is moving around the sun at 67,000 miles per hour. So you see, when we talk about speed, we have to convey a little bit about what it is that we're measuring that speed relative to. Before we move on, let's consider some slow things. I saw some of these when I was in Costa Rica. The 3-toed sloth, top speed of 0.15 miles per hour. If we were in class and we were to have this sloth race against Connor Crop, we would find that Connor could start at the front of the room and run across out the back door, go twice around the track, and come back in time to see the 3-toed sloth finally get to the back wall. 3-toed sloth, top speed, 0.15 miles per hour. And here's the snail. The snail is 0.002 miles per hour. And that's when it's really having a good day. Snails, very slow. Here's a glacier. This is the slowest thing I could think of. 5 times 10 to the minus 4th. So that's 0.00005 miles per hour. An object is moving if its position relative to a fixed point is changing. If we take a look at Usain Bolt, his fixed point that we might reference is the track itself. If we take a look at the glacier, we watch it as it moves relative to the mountain itself. Indy cars travel around and around in a circle. We measure their speed relative to the track. All things have to have some sort of point that we reference in terms, point or points that we reference in terms to calculate their speed. We will just make the assumption in the problems and conditions that or situations that we consider that we will always be referencing the Earth, the surface of the Earth. Right? You can calculate the speed of an object by dividing the distance covered by the time it takes to cover it. Whether that is fast or slow, it doesn't matter. The distance covered divided by the time will give you the speed. To describe the speed, you need to have a number plus some kind of units. Miles per hour are well understood by most of the people in this class. Kilometers per hour, maybe a little bit less so. We will use meters per second for this class. So, for instance, if a cheetah covers 50 meters in a time of 2 seconds, 50 divided by 2 would be 25 meters per second. We divide the numbers and we divide the units also. Meters divided by seconds. Meters per second is what we say. There are different types of speed. You should be aware of the different types. There is something that we can refer to called instantaneous speed. If we take a look at Usain Bolt running down the track, his top speed might be 11 meters per second. That would be his speed at a given instant in time. That is his instantaneous speed. At some earlier point he was going slower by a little bit maybe. Okay? A car driving down the road, you can get an instantaneous speed if you look down at the speedometer. Police officers can get very, very close to your instantaneous speed using radar. The car actually has to travel a certain little distance in order for it to work, but it's such a small distance you could approximate it as instantaneous speed. Okay? Speed at a given instant. So another type of speed then, and this is one that you're going to be probably more familiar with, is average speed. Average speed. In a trip that you take, you might be stopped picking up some goodies at a convenience store or getting some gas. Perhaps you need to go to the bathroom. At any rate, you're stopped at a stop sign, wherever. But over the course of the trip, you could keep track of time and keep track of the total distance that you covered and calculate an average speed. The total distance divided by the total time it took would be your average speed. So for example, a distance of 240 kilometers is traveled during a time of 4 hours. You would get an average speed of 60 kilometers per hour when you take the total distance and divide it by the time. 240 kilometers divided by 4 is 60 kilometers per hour. This is an average speed. You were going much faster than that at times throughout that trip, but on average, that's what you did. I want to distinguish speed from velocity. Alright? Whereas speed is a description of how fast an object moves, velocity is how fast and in what direction it moves. So velocity and speed are very, very, very similar. Velocity gives us a little more information though. Velocity specifies a direction. Speed is a scalar quantity. It doesn't take into consideration direction. But velocity would be a vector because it takes into account direction. The third type of speed, or velocity, would be constant velocity, or constant speed. So this means that you're not changing the speed at all. But if you have constant velocity, you're also not changing your direction. A car traveling around and around in a circle can't possibly have a constant velocity. It can have a constant speed, however. You could be going 10 miles per hour around and around and around, but because you're changing your direction every instant, it can't be a constant velocity. That's the end of this lesson. Answer some questions at the end. Bye-bye.